What's the argument?
Apparently, we're going to get
The
one sometime, but this Mathias guy just all he can do is call names and like get frustrated.
the Morris
Projection.
Poland argument.
I have not called you a fucking name yet besides a liar, in which you are, because you declared shit on me, saying that I presented the Black Swan argument, which I have not, because I don't even know the fucking argument. I'm not going to present a fucking argument that I don't even fucking know about.
So you have no argument about the globe.
Alright, there's the
That's
argument.
not what I said. Straw man.
Okay, we got the argument against the globe right now in chat.
Okay, how does it
There's
say? How does it suggest the Earth is not a sphere?
Look,
Well-
I posted some rendering some trees. Look, this is amazing. You can't deny that. It's a real time.
Yeah, people. Yeah, yeah. Computers are cool.
Yeah, that's a tree in real time.
Okay, let's come back to that later. Because
You realize that there are thousands of leaves there, and you have to calculate for each one of them the direction, the movement, the whatever, according to the wind. This is crazy. So we can do this now.
Okay,
Yeah.
TikTok. So show me an example of this being applied to the scene that I posted with a human who's interacting with the objects.
Man, I gave you a piece from the Expanse, okay? And I asked you, is it real or not? So you can't
No,
tell the
that's a TV
difference.
show.
My piece versus your piece, they're the same, okay?
No,
Same
completely different.
complexity.
It doesn't have the same physics, and it's not interacting with all the particles everywhere.
How does the fact that we can do CGI mean that the Earth is flat?
Who made that claim?
Brenda, they're just responding to a video I posted from the ISS of Chris Hadfield playing with the washcloths in the water.
Oh, okay. Well, that was several years ago.
Yeah, I was just kind of curious how they think everything's fake. Like, they hand wave it as, oh, there's computers, so this must be fake.
Yeah, that's just a conspiracy theory.
Yeah, and I have yet to see a solid argument about how that could be faked.
So, do we have a demonstration
Told
of
you a
the
while
first?
ago and you denied it.
Do you have a demonstration of the first premise P in that argument?
That's the claim.
Yeah, can you demonstrate that claim?
You guys can't demonstrate it. That's what you guys claim it is, though.
No, if
That's
you
a
make
misrepresentation of the claim.
if you make an argument, it's only true if all the premises are true. So you have to establish.
So you're saying the radius is wrong?
No, I'm not saying the radius is wrong. I would question the claim that any horizon distance measurement must be no more than 1.225 square root of observer's height.
So what's the maximum it could be?
This is your argument, not mine. You need to prove it.
Well, according to that math, that's what it should be.
So,
Measurement.
Righteous, wouldn't the intellectually honest thing be here? A conclusion from this, since the horizon is further than that, supposedly, how do you get that the Earth is not a sphere from that? Because it could just be a larger sphere.
Because the horizon should be before. We're attacking the how do you say it? We're attacking the model that's out there right now. So we're attacking the sphere at that radius.
At that rate,
So
that's
it
not what the
cannot
last
be-
sentence says, though. The last sentence says the Earth is not a sphere. It doesn't
I
say
got
not
you.
a sphere.
I got you. Well, we can scratch that out if you want, and we can say not a sphere at that radius.
Okay, but then what about the picture that shows the horizon very close? Does that prove that it is a
That's-
sphere of that radius?
That's a white swan. It takes one
So
black
we
swan.
have
It takes
two
one black.
We have two
on.
competing images.
Let me give you an example. He's showing a white swan. It only takes one black swan to dismantle this claim that there are only white swans. That's
Yeah, that's true, but this is not a black swan because the claim is not true.
So you're saying that photograph with the horizon past the oil rigs is not true?
How do you reconcile it with a photograph where the horizon is very close?
I'm telling you, this is a black swan and that is a white swan.
How is it a black swan?
It's a black swan because you guys claim there are only white swans, and we're showing you black swans, and telling you they're. It's not true. It's not true that it's only white swans.
So the white swan argument is that the horizon is never further than X miles, right?
Yes.
Okay, well that's a misrepresentation of the claim of the globe.
That's
Well,
the present, or that's the
geometric. Yeah.
in concordance with what we've all been presented the globe to be, though.
No, this is your guys
According,
making up
and
an
this
argument.
is no, this is all. I'm not done. This is all
Why
according
did you pause?
to the heliocentric. I'm not done yet.
If you
Shut
take
the
a
fuck
long
up.
ass
Just
pause,
hold on, Flat Earth. Jeez.
Can you shush this motherfucker up,
Yeah, I
Ruckus?
got him.
Thanks. So, we are going off of the heliocentric priest claim of how big the Earth is. Hence, why it's the black swan.
Yes, but we don't claim. The problem with the argument is that it commits the fallacy of equivocation, because it's equivocating between the apparent horizon and the geometric horizon.
So, are you now saying that what we've all been taught about how big this globe is incorrect? Or
your
No.
claim that the horizon should never be further than this formula on a globe of that radius is just wrong.
wow, it's wrong. Well, I'm a believer now in the globe.
Do you want to know why you're wrong?
Well, preferably, I'd rather hear why than just someone declare that it's wrong and that be
Okay,
it.
I'll tell you right now, because you're not accounting for atmospheric effects.
Specifically, refraction.
Okay, so how does that work?
So does refraction only work in hot weather conditions?
Wait a second. We don't even have to go that far, actually. But yeah, sure. All right, let's go.
The fact that you have two images of this exact same location that have completely different results tells you that the atmosphere is disrupting what you're trying to see. So this idea
Okay.
that there's a simple formula that calculates how far the horizon should be must be wrong.
Okay, so that means you guys have no math for the Earth, for the ball Earth.
Oh, we do. We have math for calculating the amount hidden given the height of the observer, and we have math for calculating refraction. And one of the other problems with this image is that there is no data on what the weather conditions were that day.
So how much does refraction account for in Make West calculator?
It depends on the weather conditions, on how strongly.
Well, let's go right now. Does that Make West calculator have weather conditions?
Walter Bislin's does.
Walter Bislin's. Okay, let's go. So the advanced curve calculator?
Yeah, Walter Bislin's advanced curve calculator will account for refractive index, if you know that, but I don't think any of that is known.
So, hold on. So you're saying this curve, this refraction, can take a geometric horizon at like 1-something miles and extend it to past 9 miles?
It's not extending, it's just disrupting the light, and all you ever see of an object is its light. So what's so hard to believe that the light hitting your eyes coming from the ground is disrupted?
Also, the
I'm fine with the light. Go on.
It's okay. The geometric horizon is fixed. What you're seeing in that image is the apparent horizon, not the geometric horizon.
So then that means we can never see the geometric horizon. It's always
Right.
an apparent horizon.
We always see the apparent horizon. Therefore, the argument is fallacious because it equivocates between the geometric and apparent horizons.
So if we only see the apparent horizon, the geometric horizon is assumed. The geometric horizon of the ball is assumed then.
Geometric horizon is calculated, and sometimes the apparent horizon is exactly where the geometric would be.
Right. When there's
No.
he's correct. When there's very little refraction going on, the geometric and apparent horizons will be right on top of each other, or at least very close, or indistinguishable. But under high refractive conditions, the apparent horizon can be very different from the geometric horizon.
But this A.T. Young guy says you really only see a rough approximation of the horizon.
Which is exactly how you get the image that you guys call a black swan.
Yeah, he says specifically that, at least in the parts I've seen, that there are three horizons: astronomical, apparent, and geometric. Right, and he says that we only ever see the apparent horizon because things are almost
so that
always
goes-
because there's always refraction going on, at least even to a small extent, at least.
Okay, so that goes against what you said before. That we can see the geometric horizon, but no, we can't. We can never see
Huh?
it.
No.
I thought you said earlier that we can see it on like low whatever
They're very
certain
close.
weather conditions.
You can't see it, but the apparent and the geometric horizons would be either right on top of each other or very close to each other when there's little to no refraction going on. But you're
But it's never.
almost never going to have no refraction on Earth.
Not almost never. It's
Yeah.
like never.
But on the moon, if you were standing on the moon, all you would ever see would be the geometric horizon because it has no atmosphere.
That's not true. They say that the moon does have atmosphere now. The Earth's atmosphere extends past the moon.
It might no, but that's molecules. That's atoms per cubic meter or something like that. It's not it's not an atmosphere that can affect things. They're counting atoms at that point.
Why are you citing NASA anyway?
Hostile witness.
Sure, I mean, you have to resolve that contradiction. You're going to simultaneously say that everything
I'm just
NASA
using you guys' argument against you. That's what I'm doing.
No, you're not. You're using a different version of the argument that you made up.
No, there's articles about it that NASA says or somebody says that now the Earth's atmosphere extends past the moon. And
Which
I'm
part
using
of
the
the
mainstream narrative against you guys.
Oh yeah? Which part of the atmosphere does it say?
The atmosphere? What was that? Aren't we in like the I don't know, stratosphere or something? Mesosphere?
Right.
One of
They
those
call
Can you
it-
read more than the headline? Which part of the atmosphere was the article saying?
I don't know. I'm gonna look it up, I guess.
They call it
troposphere.
Exosphere is
Yeah.
what you'll find out, which is the rarefied, negligible amount of gas at the furthest extents of our atmosphere.
Oh, right under the dome.
So by saying exosphere and hemisphere or an atmosphere, are you already presupposing a sphere?
No, that's the word we use for the gases that surround the Earth.
But
It conditions you to think about a
in it.
sphere, though.
No,
yeah.
if you study the entomology, it has nothing to do with that.
So sphere
That sounds
doesn't
like
mean
they
sphere.
assumed a sphere instead of a plane. Let's call it the exoplane, the
How
atmos
about we
plane.
stay on the argument that Wright just brought up instead of devolving into semantics?
Fair
Yeah,
enough.
so no geometric horizon. There's no Earth.
Also, you're talking about
Sure.
two horizons, so show two horizons. Show positive evidence of a geometric one and an atmospheric one, or rather an apparent one
Why
that
would you
is
ever see
doubling
both
somewhere
together?
else beyond the geometric. You haven't even put up proof of two horizons.
Why
All
would you
we
ever
see
see
is
both at
one.
the same time, Discord?
Then how you need to do that to say you have positive proof of a geometric horizon and an apparent one. Otherwise,
you
if you don't have positive, you have nothing to talk about.
False premise. Argument discarded.
Stop interrupting
premise.
everybody.
Real premise. You
You're making
can't
a
call
claim.
yourself a logical positivist who needs to have a one-to-one correlation between reality, math, and all your constructs when you can't even see a geometric horizon and an apparent horizon doubling beyond that or before that. You
Why would
can't
you see
do
both
that.
at the
It's
same time?
logically untenable.
Why would you ever see both at the same time?
if they don't exist, how can you say that you have a geometric horizon when we don't have visual proof that they exist? That's illogical.
If you hold up a ball in front of your face, you can't see the other side of the ball. There's a horizon right there.
We have optical obstruction also, not just geometric or physical obstruction. So we need to open our minds to whether or not it's an actual ball or if it is just all optics with no ball, just a flat plane, no
What-
obstruction.
What are the
Optics proves
conditions?
it's a ball.
What are the conditions for optical obstruction?
The light rays have to be crowded on the optic. Two light rays have to focus on the sensors of your eye at an angle that's lower than 0.02 degrees, around there. It's different for each person because each person's visual acuity is different. But that's around the roughly the point where two rays merge into one and you get a horizon line.
No, that's not how it works. You're talking about
That's-
angular resolution.
Yep, that's basically what the horizon is. Angular resolution of the sky and ground focused on the sensors of the eye. That's it.
But that's not obstruction.
Prove it.
What was that, Brendan?
That's not obstruction. Angular resolution is not obstruction. You said that there was optical
Effectively-
obstruction.
Well, effectively, your eye interprets it that way because you only have a 6-foot zone from your eye line down, converging against an infinitely big zone from your eye line up. Your 6-foot zone from your eye line down will only symmetrically pair with the 6-foot zone from your eye line up. So you're going to get a 6-foot zone from your eye line up and your eye line down, 12 feet total. That will converge evenly in the distance at the limit of angular resolution, and anything that's taller than that, beyond that zone, will set beyond. That's all.
That's not
Everything you said is just word salad. Makes no
It's not,
sense.
yeah, it's not
Well,
recognizable science.
otherwise,
That's not
what was that?
science. That's not
That-
science.
that's optics.
No,
That's
that's
optics.
not that's not optics.
so you're saying that objects don't disappear down to a vanishing point like a 6-foot zone from your eye line up and down? Because that 12-foot zone would have a vanishing point effectively at the horizon, don't you think?
Objects objects do
And
disappear.
anything bigger will just set beyond because it'll want its true vanishing point beyond that zone. But there's not enough room to treat a true vanishing point visually. So it will have to set into that zone beyond and go to its true vanishing point, which is out of frame.
None of that makes any sense with modern optics.
Objects.
That makes a lot of sense. A 12-foot zone has its own vanishing point. The 100-foot building that only has 6 feet below your eye line and 100 minus 6, 94 feet above your eye line wants the vanishing point for a 94-foot object up and down, but only has 6 feet from your eye line down. So the
So
6 feet is
if I
going to
get
vanish
far
out
enough-
evenly.
So if I get far enough away from the building and the windows at the top are close together, why doesn't the top of the building just fucking disappear?
It converges to a line.
But it doesn't disappear.
It converges to a line.
No, I can still see the building. It doesn't disappear or get smaller or shorter.
Well, where are you looking?
The top
Because
of the
your
building.
eye line will eventually cut the building into a top and bottom half portion, depending on where you're directing your eyes.
No,
And
I
that's
assume you're looking
irrelevant.
beyond the building to the sky, which means that there's none of the building that's distributed above your eye line based off of where you're looking. So that
This guy
example
has
wouldn't
absolutely
apply. It
nothing
would just
to say.
converge.
Let's not even respond to this guy. He just has random words that make no sense.
Um,
Who has an
You
actual
can't,
argument?
you can't visualize it in your head, so you don't really understand the argument. I'm going to put the video in the chat that will help you think about this. Please watch it.
Can you actually use words that make sense when you describe things?
There are words that make sense, you just can't visualize it. It's not my fault that you're aphantasic, that you can't visualize anything. And I'm not breaking out any models, that's too much work. Let me
I
put the
can
video in the chat.
understand-
Yes,
It's-
nothing that makes any sense whatsoever. Does anybody have a real
Hold on a
argument?
sec. If you don't understand, it's okay. You can maybe try to explain better, or he can show you the video, like you said.
Well, things that
Yeah, but he's not
are-
even using accurate terms. He's just mishmashing words that sound scientific, and he's not even using like nouns and verbs properly.
That's just your assumption.
No,
No,
sorry.
if somebody
None of this
uses
is actually
words,
testable.
if somebody uses words in a way that leads to a contradiction, a logical contradiction, then it's not something that can be understood. Somebody could say something fictional, and if it was logically consistent, you could understand it. So you could understand a fantasy world where physics works in ways that are unlike they do in the real world. As long as they made sense, you could understand it. But if it leads to logical contradictions, then it's in principle cannot be understood. So with a 100-foot building, like Lemon was talking about, the top of that building will never ever go below the vanishing point. It will never do that, because that's how the laws of perspective work.
It depends on where you're looking. If you're looking up into the sky, there's none of the building that's distributed above your eye line because your eye line is above the building in the sky zone. Now, if you're looking at the building and cutting the building in half, now you need to have a different condition. The building needs to go off in the direction that you're looking, where you're bisecting the building at that angle. So the building needs to jump out of the ground and go off at the angle that you're looking at the building. And then when you do that, you will see this behavior. But most of the time, people are looking at the sky. They're not bisecting the building when they're looking at it.
So if I just
They're
take a
just looking up
picture,
into the sky.
what if I don't even use my eye? Just take a picture or something. None of this applies.
Yes, it does. It applies based off of where the building is going off to in the distance, or over a flat plane, something would go off into the distance over the flat plane.
How is
So
the
something
building
is
going off
effectively.
in the distance if I take a picture of it?
This behavior only applies to where stuff is converging at when it's going off into the distance parallel to your eye line. That's
Okay,
the only
so-
time it applies.
Building off in the distance, the lower part is not visible, the ground is in front of it, but the top part still is visible even though it's the same distance away. Explain.
Yeah, the ground is converged because the 6-foot zone above and below your eye line is converged very quickly.
The
It has
ground does-
very little room before it reaches a vanishing point, but the rest of the object that's taller than that needs a whole lot more room and will converge into your eye line beyond.
How does the
Now,
I put the
ground?
video in the chat. Let me put the time zone. Please go to an hour and 9 minutes. It goes to a better explanation than I ever could. Hour 9 minutes into the video, it explains everything.
How
Alright,
does
this guy's
the?
just full of nonsense.
Yeah, I know. I understand. How does the ground get in front of the building?
It's just the way your eye treats it, because all of the light from the ground and the sky is just converging very quickly at that point,
But-
because it's only 6 feet from your eye line down. That's
That
going to
can't
reach a
happen.
vanishing point very quickly.
That can't happen optically. How does the ground?
It happens optically all the time.
No, it doesn't. It can't happen. It logically
Okay, hold on.
cannot happen.
That's an argument from incredulity, Brenda.
No, I'm saying it logically cannot happen. That the ground could move and come between me and say a building. How is
Just
that
because you
possible?
don't, just because you can't imagine it, or you can't. How do I say it? How does that argument work for argument from incredulity?
Well, the thing is, we already have precedent for it. You put a small coin in front of a huge building, it has the ability to optically block what's beyond, even though
Oh,
it's much smaller than
well,
it.
it's
It's
not-
the same thing with the convergence zone.
Lemon.
How is that the
that's-
same as a convergence zone, which isn't even a fucking term?
Lemon.
The convergence zone, the vanishing point for a zone 6 feet up from your eye line and 6 feet down from your eye line, a 12-foot zone. You can treat it like a 12-foot pole.
Artistic renderings. They have nothing to do with real optics.
Yeah,
Lemon,
but you still need to render that into your eye's visual frame and its visual impression of the world. Your eye is just trying to give you an accurate, faithful 2D rendering of the world that is proportional without distortion. So it has rules.
If I don't use my eye, then what if I use a picture? Explain that.
It's the same. There needs to be a light on the sensor of the camera, still just like with your eye, and it needs to be spaced enough, far enough apart on the sensor of the camera to give an impression of two visual fields. Now, if you have two light rays that are focused so close on the optic, it's not going to be able to differentiate two visual fields and give you a 2D image. All you're going to get is one pixel and or just a
It won't be
line.
disappeared. It'll still be there.
No, it'll be unresolved visual information, and eventually you'll get a line anyway.
So how can I
It'll have
see?
to.
How can I
Uh-huh.
see a beach if I can't see individual grains of sand?
Your eye fills in the blanks, but the individual grains of sand, like you say, are gone, but the overall size of the beach is still meeting your eye's conditions. First of all, it has to be focused on the center of your eye.
So why does a building get shorter as though part of it's cut off?
Because you're dealing with things in a symmetrical 2D fashion. You're only dealing evenly with the 6-foot zone above your eye line and down. For all intents and purposes, it's like dealing with a 12-foot pole that has reached vanishing point at the horizon. And
So
then the rest of the object that's taller than that still needs to set, but it's going to set beyond because it doesn't have enough room in your eye to be treated with a faithful 2D rendition.
Okay,
That's all.
so all that applies to a beach and the grains of sand, but we see something different happen. And the beach doesn't change its physical size. So whatever you're saying just doesn't make any sense.
Well, the beach is pretty big. And actually, it does change size because when you walk up on the beach, it appears to expand and get bigger and bigger. So what you're saying doesn't make logical sense. It does change size.
Lemon, you said earlier that if you
I
hold
put the timestamp on the video, 1 hour 9 minutes. The rays with which we view an object have different angles above and below eye line. The optical information above the eye line is paired with the information below. As one angle opens, the other compresses. With decreased elevation, the ascent rate below eye line decreases, while the descent rate of objects above increases by a corresponding amount. This brings the horizon closer, and once the distance of the nearer horizon is met by the descending optical information from above eye line, things above will appear to set with further distance. You were saying, Brenda?
Word salad.
that you said before that if you hold a penny up to a building, you can make the pen. That was optical obstruction, but that's not optical obstruction. That's physical obstruction. There's no such thing that I'm aware of as optical obstruction. Light waves can't obstruct other light waves. It can't happen.
But Brenda, how can you call it a physical obstruction when the coin is smaller than the object it's obstructing? If you put that object next to the object side by side, you will see that it's much smaller. And at best, you can only block a little section of it while the rest of it is actually taller up and down from that coin. So how can you say that? That's optical, not physical?
It's physical because the penny is physically preventing the light from reaching my eye. If I put the penny right up to my eyeball, all I can see is the eyeball, is the penny. Oops. All I can see is my penny. And so it blocks everything. It blocks the whole world. But it's not as big as the world. It's just in front of my eye, preventing light from reaching my eye.
Well, then how much of, say, let's apply this to the geometric horizon. How much of the actual geometric horizon is actually obstructing what's beyond? What if it's like the penny, and at best you only have a penny's width of the supposed curvature of the Earth, when you have much bigger buildings and much bigger objects beyond, the penny width, horizon beyond, that are not actually physically obstructed, just visually. It's the same phenomenon. Because basically what you're saying is the hump of the Earth isn't really blocking or big enough to block what's beyond. It's just a visual phenomenon at best. But when you get up closer, you'll see that the land really isn't in the way, and that for all intents and purposes, it's flat. So either it's big enough to block the object beyond, or it's not.
Yeah, the Earth is bigger than anything on the Earth. Yes. So it is big enough.
Anyway, all this is optics. That's all it is.
No, but we're not talking...
Yeah, we have to make a coherent argument about that.
I'm not talking about optics. It's physical obstruction. Something is in the way. The reason, like...
The light is in the way.
Light can't get in the way of light.
That's not true. If somebody shines a flashlight in your face, you're not going to see anything beyond the flashlight because the light... It's just exciting the sensors of your eyes so much.
Let me have a quick go at this. If you see in perspective, you're seeing converging lines, correct?
That makes zero logical sense.
He
Brenda?
asked a question.
Yeah.
So
it's
if
just
lights have a convergence, at least according to how we visualize things, eventually they'll cancel each other out because they'll just be too close together.
I can't even get past your first statement. It doesn't make any sense. Lights have a convergence. What the hell does that mean?
We see things in convergence, is what I'm saying.
We see things in parallel planes. So you treat objects that are a foot above your eye line but no further, they will appear to converge at a 1 foot plane above your eye line and the same below. So that plane of vision will appear to converge at the middle of your vision. Same with the 2 feet above your eye line, above and below, 3 feet above and below, 6 feet above and below. Correct.
Yeah, but
straight objects arranged that way, yeah, but we don't have just plain
Yes, we do. It's called Rayleigh's criterion, yo. Just look it up.
That
has to do with the ability to distinguish two close objects in wavelength of light.
And those two objects now are planes of vision. Yes, Brenda?
No, wrong.
The railroad tracks never actually meet. right? Right? I mean, you
Exactly.
understand that. They never meet.
Yes.
So it's only an
No.
apparent convergence. They don't
Correct.
actually converge. The
Correct.
telephone poles receding in the distance never actually meet the ground.
Yes.
Yes. So it's just
They only seem to because they're so close together you can't tell. And that's all that we have with the sky and the
Yeah.
ground. We can't tell. It's just too converged. It's just convergence.
Right, but that's not what we're talking about when we're talking about obstruction due to the curvature. It isn't because things are too close you can't tell. It's because something is in the way, and that something is the Earth.
But the thing is you're interpreting it as something being in the way when really all it is convergence. Nothing's in the way. It's just converging.
Well,
The 6 foot
they're fundamentally different, Lemon. They're different. It's not converging. It's obstruction.
It's just like with a book, Brenda. A really thin book. Open up the book; it'll make a nice wide angle when you open it up. Take the book and face the binding away from you so that the pages open up to you. That's basically your vision. It opens up like that, but then eventually it closes. It won't close completely, but
That's
it
not
will
how.
get really compressed like a letter. So it's just really compressed. But from your eye line up, from the middle of your visual, field up and down, it can open up and give you a much wider angle, just like that book. It's just really compressed.
That's not anything like how vision works, or
But
light
you would
works.
just interpret it as an obstruction, but it's not an obstruction. It's a false impression.
Your vision doesn't work like a book, and that's not how light works. It doesn't work
Actually,
that way.
Well, when you walk up on
Okay.
a city, doesn't it open up like a book and
Let
get
me-
wider and wider?
No, it doesn't. It doesn't open up like a book. No.
Really? So the stuff that's to your left and right doesn't get out of your way and kind of expand to the left and right as you walk up on the city line? It
hell is
doesn't
he
do that
talking
and open
about?
up like a book? It's something visual. You're not visual, so I'm not writing a model for you. Just watch the video.
I
You don't.
understand what
He's
you're
wrong.
saying.
Sorry.
I think I
Yeah.
understand what you're saying. You're saying that because you have this convergence line, and that as you approach it, things open up like a book in front of you and reveal themselves.
All
But
right.
that's not what happens. What
All
happens
right,
is
all right. Hold on. I got a demonstration of this. Okay, so I'm gonna post it in chat. Tag to. Let's go. Okay, it's there. Does that look like opening a book almost?
no, it doesn't look anything like opening.
So what's blocking? What's blocking?
Nothing's being blocked. I can still see the object.
No.
Yeah, there's nothing being
As
blocked.
You tell
as
that
the
it's two
objects
discs.
as the objects merge together, there's something clearly being
No.
obstructed.
Nothing's
Because you're not
being-
seeing two spheres anymore.
nothing's
You're
being
seeing only one
obstructed.
now.
Nothing's being obstructed. You're just being. This is your ability
Correct.
to
Correct.
resolve.
If we're being
Yeah,
correct, it's not being obstructed. It's the ability to
correct.
resolve. Okay.
right. And we're talking
now-
about obstruction, not the ability to resolve.
Okay. Now let me
But the
post you
thing
guys.
is-
Let me post you something else. Watch this. I just flipped it. And look at that.
Uh huh.
So you guys could make the same case for like something on a plane
Yeah. This
Basically
is
the
this is
object
just-
and the horizon merging together,
yeah, I
giving the
understand.
illusion of obstruction, but it's not really being obstruction. It's just the illusion.
That's not obstruction. That's not what we
I
see.
know. It isn't obstruction, of course.
But
But
your
it looks
eyes
like it's
interpret it as obstruction
That's
because it's just the compression of visual information. Your eye will interpret it as obstruction falsely. It's just those two airy discs. They appear to merge into one, and after a while, you can't tell that there are two airy discs there. For all intents and purposes, your eye's going to think that one airy disc went behind the other.
Wait a minute. The area disk demonstration applies to point sources of light, and the ground and buildings are not point sources of light.
You can think of it as like light blocking light beyond, or rather, light being so smushed and converged on the sensor, no more optical information can be interpreted as separate visual fields. Just a
So-
line.
So what you were showing is angular resolution, and that's what is partly the photograph I just uploaded is nothing like it. It's obstruction. It is not merging things because of our inability to resolve them because due to diffraction. This is obstruction. I can resolve the details of those platforms just fine. I just can't see the lower part because it's obstructed. There's something in the way, and what's in the way in this case is the ocean, the curvature of the earth.
It's just how your eye interprets what's going on with the light. If nothing's
Let me
going
ask you
above or
this,
below
Mark.
anything.
Can I ask an important question? Okay, so what about the flat parts of the platform that are very close to the other parts of the platform? That's a flat plane close to something, but we don't see those parts of the platform disappearing.
Well, the thing is, you're focusing on the 2D image readout, the picture that we have here, but that's after the work has already been done by the sensors. So you need to focus on the work on the sensors. In that, the light has to be spaced enough on the sensors and spaced enough far apart beyond the limit of angular resolution, 0.02 degrees roughly, or whatever for the optic that you're talking about, whatever camera you're talking about, whatever angle that is. It has to be separated enough on the sensor to give you two visual fields. Then the 2D image that we're looking at now is rendered. So we
Can you
need to
respond
focus
to the
on
point that I
sensor
brought up
first.
instead of just random words strung together?
I did. You need to focus on the sensor. You're focusing on the 2D image after the sensor has done its work, which is too late. You need to
That's
focus
what
on the
all
light on the
that's all
sensor.
we have here. That's what you're focusing on too.
It's too
'Cause you're
late.
saying,
The image has already been interpreted. And the
no.
stuff that is beyond
How
angular
can we use
resolution
this
will be
picture?
read as a 2D image. The stuff that is too narrow, below 0.02 degrees, will be nothing but a line and unresolved. So you're focusing on the 2D picture, which is too late. You need to focus on the sensor.
Lemon, there are. I'm trying to explain this to my best of my ability. I'm trying really hard. So the diffraction image that Righteous posted is an example of diffraction leading us to be unable to resolve two different objects. The objects never actually get closer. It's that as they get further away, our ability to resolve them into two is simply not possible due to diffraction. And then
Correct.
in the image which I posted, it's a different phenomenon. It's completely different. It's obstruction because there is something in the way and is preventing us from seeing the rest of the image. So there are two. One is because we can't resolve it, and so we can't see all of it. And then the second one, we can't see all of it because there's something in the way. These
So
are
how do you
two.
distinguish between the two?
Well, in the second case, you can see the details, and that tells you that you're not having trouble resolving details. The fact that I can see the cranes and the legs, the supports, I can see details on the platforms shows that it's not a problem of resolving details. It's a problem of the fact that the ocean is in the way.
Yeah, good point. How come the width of the cranes is not smushed?
You have more compression up, down than left, right, which is expected. You have
Why?
your eyes laterally, well, for one, you have your eyes laterally distributed in your head. So you
So if I
have visual
rotated my head
information
90
coming
degrees, I would gain
laterally
everything.
more than you do up and down. What was that?
So if I'm in landscape mode with my camera, then the crane would be smushed all of a sudden.
Landscape, you mean like going left and right?
Well,
What do you mean?
he's talking top to down being smushed.
No, look at the width of the crane, the whole platform. It's not distorted like it is vertically, apparent according to you.
Most of the smushing will be vertical, yes, because your eyes
Why?
are distributed left, right.
So if I rotate
Your,
my
your
camera
brain.
90 degrees, then suddenly the whole platform would be distorted in a different axis.
Well, you have a brain which is distributed laterally, eyes
I didn't talk
distributed
about a brain.
laterally, and
I talked
therefore
about a
you are
camera.
going to have more information left, right than you're going to have up and down. That's just logical.
I brought up a
Wow.
camera, not my brain.
Well,
It still has to bring light to your eye, so your eye is still going to interpret the information. And your
Lemon,
lateral brain is going to interpret the information a certain way anyway, with or without the camera.
Lemon, I'm going to take off. I tried my best. This is the best I can do. I don't know how to make it more clear than I've already made it, but I gave it a shot.
Don't worry, Brenda. This stuff takes time. We got to get used to each other's communication styles and come to the middle a little.
I don't have a problem with you personally, Lemon. I have a problem with the things that you say that don't make sense to me.
Well, before you leave, you've seen a focusing diagram on the lens of the eye, right? Where you have ray tracing through a lens, and you converge the rays of light beyond the lens. You've seen those diagrams before? Have you seen those?
I'm not 100% sure what you're talking about, so possibly
I'll
not.
put what I mean in the chart. Let me see right here.
Well, thanks for coming, Brenda. Before you leave.
Yeah.
I was just going to give an example of why we have a hard line, even with all of this, ray tracing through the lens of the optic.
When
let
you
me
say
see.
stuff like that, I don't know what you're talking about.
Understandable, but basically, this is what I'm talking about right here in this thumbnail. I'll put it in the live chat. That's basically ray tracing through an optic where you trace the rays through the lens and converge an inverted image beyond the optic. You see that?
Ray tracing. Why are you
Okay.
using words that are unnecessary?
Yeah, I don't
This is
Ray
just a
understand.
tracing
path.
That's
because it's the
throwing me.
tracing of the rays of the light. Do you have a better way to describe that?
Yes, you're throwing in mumbo jumbo word salad. This is the path of light as it enters your eye and hits your retina.
And we
Yeah.
trace the path of light through ray tracing. Is that correct?
No, ray tracing is some other technical term for something else.
No, it's ray tracing. You're just not
No.
used to the way that
Well,
it's referred to, and
yeah.
you're getting stuck on the semantics. You need to be flexible. But the point is, there's going to be a
Stop using
midline
word salad.
between those rays that basically everything is going to converge toward. Can you visualize that midline between those rays there, Brenda?
I'm sorry. I'll take some time to look at it some other time.
Okay.